Hello everyone. Today I'll be doing a quick tutorial on how to use the program PSPICE and show you how to do the experiment number 1 on the EC240 lab manual and just show you some basics on how to use PSPICE in general. So first things first, to get the program on your computer, there's two ways to do it. So right here on Google, I typed in ORCAD PSPICE free trial, and I'm going to go to this link down here. So if I click on start your free trial, it would start the process on getting the 30-day free trial. So if you are planning on using this program for say a whole semester or longer than 30 days, then this is definitely not ideal for you. So another thing that you might want to do is go on Google, and then you're going to type in ORCAD PSPICE student. And then you're going to click on this link down here called ORCAD academic program. So what you're going to want to do is you're going to want to fill out all this information. And this process is to get a 1-year access of PSPICE. So rather than the free trial, which only gives you 30 days, this would give you 1 year. So if you're going to be using it for a semester or two, then this is definitely the more ideal option. So now I'm going to quickly take a look at the experiment number 1 in the EC240 lab manual. So just skipping down all the instructions, what I'm going to be doing is I'm going to be recreating this figure 1.3 in my PSPICE program, and I'm going to be simulating it with a DC source, a sinusoidal source, and a pulse train. So this is the figure that we're going to want to create. So a voltage source in series with 2 resistors. So after you have the program on your computer or your device, you're going to see this icon, and I think it's usually called Capture CIS. So once you open that up, you're going to see this start page. And so we're going to want to create a schematic from scratch. So I'm going to start by going to File on the top left. I'm going to go to New. And then I'm going to go to New Project. So you can pretty much give it any name you want. I'm just going to give it some arbitrary name like ECE 240 experiment 1, like that. And then as far as the location goes on where you want the program to go, you just click on these 3 dots, and then go from there. And you're going to want to make sure that you click this box, Enable PSPICE Simulation. So if that wasn't already checked, you would check that. Moving on, you're going to see these 2 options here. So one is create based on upon an existing project. So these are pre-made circuits basically within the program. But again, since we want to make one from scratch, we're gonna click on a create a blank project. I'm gonna hit OK. And now this is what we see once we create that blank project. Down here, you can fill out this information for documentation purposes. So let's say I wanted to put the title right here. I would double click right there on title, and then just type in whatever name. So I can do like ECE 240L and just leave it like that. And then fill it out however you would like. So before I start placing down the components for the circuit, what I like to do is to zoom in on the interface. So I'm going to go to this magnifying glass right here and zoom in. And then now we have like, again, a more zoomed in space. So it's easier to see all the parts, because if you don't zoom it in, they're going to be kind of small and it's a little hard to see. So again, we're going to go back to the circuit, and this is the one that we want to recreate. So what I like to usually do is I like to start with the source. And that one right there on the circuit we just saw is a DC source. So in order to access all the parts in general, you're going to want to go to the top toolbar and specifically go to Place. Then you want to go to PSPICE component. And since I want to start with the voltage source first, I'm going to go down to Source. And then since it was a voltage source, I'll go to Voltage Source. And again, that one was a DC source. I'm going to click on DC. I'm just going to place it down there. And then you'll see that the source icon didn't go away, even though I'd already placed it down when I left click. So in order to get the icon away and just have your regular cursor, you're going to want to hit Escape. And then now it's not following anymore. And you can continue as like normal. So now we need 2 resistors. I'm going to go back to Place. again to PSPICE component, and then I'm going to click on resistor. And then we needed 2. So I'm going to left click on one, and then since we need another one, I'm not going to hit escape just yet. And then I'm going to place another one like so. And then now that I have the 2 resistors that I wanted, I don't need anymore. Now I'm going to hit escape. And I have my cursor again. So really quick, looking back at the lab manual, we see that this R2 right here, resistor number 2, is vertically placed. But by default, when we place the items on PSPICE, they come as horizontal. So there's 2 ways to rotate the items. Well, one way is to first left click on it and make sure that it's highlighted pink. And then I'm simply going to hit R on my keyboard, the letter R on my keyboard. So if I hit R, it rotates like so. Another way to do it is if you were to left click on the item and see that it was highlighted, I'm going to right click. And then there's other options right here like mirror horizontally, mirror vertically, rotate, and so forth. So again, we want it vertically. So I'm going to put it like this. Just going to bring it down a little bit. Okay. One thing I do want to mention is that say there was an item that you're looking for that wasn't over here in place in PSPICE component. So if it wasn't anywhere here, you can also just go down to search. And then this window on the side is going to pop up. And if you knew the name of the component you're looking for, then you can simply type it in. So let's say I was going to look for the LF411 operational amplifier. I would type it in right here, hit enter, and then it would give me the options right here. So it would filter out all the other parts and then just give the one that has LF411. But since that's not what the part we need for this circuit, I'm just going to simply close this. Just want to show you that really quick. Okay, so now you can either connect the circuit elements with a wire or change the parameters. So I think what I'm going to do first is I'm going to go connect them with the wire. By the way, looking back at the circuit, we are missing one more circuit element. You can either bring that out now or bring it out later, but I guess I'll just go ahead and bring it out now. So we do need a ground. So I'm going to go back to place, to PSPICE component, and then I'm going to go to PSPICE ground. And then I'm just going to place it all the way down here. And then hit escape. Okay. So now I believe we have all the elements that we need for the circuit. So what I'm going to do now is I'm going to go connect them all with the wire. So going back to place, I'm going to look down here and I'm going to see wire. And then you see that your cursor kind of changed to a crosshair. So what you want to do is you want to click on these white boxes on the elements. You want to left click, and then now the wire is connected to that white box, or the element more specifically. So that's how you want to connect these circuit elements with the wire, by connecting them by the white boxes. So if I just move the cursor and I want to turn right, sometimes it does it by itself, or if it doesn't, you can just left click, and then you see that it stopped right there, and then continue on whichever path you want to go to. So I want to connect the source with this resistor right here, and then because we want to keep connecting all of these circuit elements together, I'm not going to hit escape just yet. So continuing on, I'm going to left click on the box, go down, connect them, go down here, and I'm not going to connect it to the ground like this. What I'm going to do is I'm going to just continue on to the source. Okay, so now I have all of these connected like so. And typically with the ground, we like to get a small wire and just connect it right here. So now this whole bottom part of the circuit is connected to ground. Okay, so now what I want to do is I want to change the values of the circuit elements. So looking back at the lab manual, we wanted a 6-volt DC source. So I need to change the value of this source to 6 volts. I'm going to double click on right here where it says 0V DC. And this window is going to pop up. So right here, you could type in the value you want. So you can either do just a number, or you can do the unit as well. So you can do 6, 6V, 6 VDC. It really doesn't matter, they're all the same thing. I'm just going to leave it at 6 because that's my personal preference. So now this source has a value of 6 volts. And now I'm going to change the resistor values as well. I'm just going to change it to 10. So 10 for R1 and 10 for R2. Okay, so now we have basically the circuit set up the way we want it to. And let's say that we wanted to measure the voltage across this resistor right here, R2. And let's say that we also wanted to measure the current through R2. So we can do both of those things using PSPICE. First things first, if you want to measure any values across the circuit elements, you need to set up a simulation profile. So one way to do it is to go to this icon right here, which says New Simulation Profile. Or what you can do is you can go to PSPICE up on the toolbar and go to New Simulation Profile right here. So again, you can go to this icon right here, or go to PSPICE on the toolbar and then New Simulation Profile. So either one works. So you have to give the simulation a name. I'm just going to name it EC240L. You can leave all of this by default, and then you just hit create. And then after making the new simulation profile, you're going to get this window right here. So because this is a DC voltage source and we just want to do a time domain or transient analysis, I'm just going to leave this analysis type as time domain transient. And as far as options go, the only one that we really need is just general settings. Now let's say you're doing your lab and one of the instructions was to do an AC sweep or a DC sweep. So what then you would want to do is you'd want to go to this arrow right here on analysis type and then change the type of analysis to whatever the instructions tell you. So if it was AC sweep, you would do this one and like so. But again, at this point in time, we just want to do a transient analysis. So I'm just going to leave it by like default. And then the run to time is how long the simulation would be running for. By default, every time I open a PSPICE, it's always 1,000 nanoseconds. I'm just going to leave it as is, but later on we'll see that changing that run to time actually matters. So for now, with this circuit in particular, I'm just going to leave it to 1,000 nanoseconds. I'm going to hit OK. And now what we want to do is simulate the circuit. So first, I'm going to show you what happens when you don't put any of the probes on the schematic or on the circuit. So I'm going to hit this play button right here. So this play button will simulate the circuit, or what you can do is you can go to the PSPICE toolbar up top and hit run from there. So both will do the same thing. So I'm just going to hit this play button up here on top. And then you're going to see this window on the bottom appear. It's usually like a black square with white squiggly lines. So I'm going to click on that. And this was from a previous experiment that I was doing. So ignoring this for now, but this is what you would get. You would get a waveform from the simulation. And then another thing that you'll notice is that there are going to be some boxes that show up on the schematic with some values. And depending on what you want to be displayed, it's going to either show like the current through the circuit, the voltage at a certain node, or the power. So I'll be going through that shortly once the simulation is finished. Okay, so now the simulation is done. One way to tell is that you don't see the pause button and the stop button basically colored. So right now they're grayed out. So the simulation is done, and you can also see right here on the bottom left, the simulation is complete. So again, earlier we had a waveform because that was from a previous experiment. Right now it's blank. And the reason for that is because we don't have any probes on the circuit or schematic. But if I go back to the circuit, like I mentioned earlier, there's going to be some boxes that have some values. So with this box right here, what it's indicating is that this is the voltage at this node right here. And for this box, this is the voltage at this node right here. So you can pretty much calculate what the voltage across R1 would be based on these values, because the voltage across R1 would be the voltage at this node subtracting the voltage at this node. So 6 minus 3 would be 3 volts. Same thing for R2 right here. We see that this node is 3 volts and this node right here is 0 volts. So 3 minus 0 is 3. Another way to confirm that would be to be using the probes. Before I do that though, I do want to tell you that the current right here is not showing. If in the event you did want to have some boxes that show what the value of the current is through the circuit, what you can do is go to PSPICE on the top toolbar, and then you would go to bias points. So we already see that the voltage is being displayed, but we want the current. So I'm going to want to hit enable bias current display. And now we have these bright red boxes. And so typically the darker ones are voltage, the brighter ones are current. But we can see that there's 300 milliamps flowing through the circuit, through each circuit element. And that's pretty much expected given that all of these circuit elements are in series. Now, it'd be good practice to also confirm with preliminary calculations on the side. So I did some preliminary calculations on a piece of paper before simulating the circuit. And I also expected the voltage across R1 and R2 to both be 3 volts. So the simulation values met my expectations. Okay, so now if we wanted to get a waveform, or we wanted to show the simulation waveform of the circuit, what we need to do is we need to put some probes on the circuit. So typically, we use these 2-prong voltage differential markers. And this is to measure the voltage across a circuit element. So when I click on the icon right here, we're gonna get this icon. So what this is like if you ever used a digital multimeter. This is like the probes on the multimeter. So when you first press that icon, the voltage differential markers, the first probe to come out is the positive one, or the red one. So when we have a circuit element placed horizontally, we typically go from left to right. And you can see they're named V plus V minus. Similarly, when we have a circuit element placed vertically, like this resistor, we would then go top to bottom, like so. Okay, so what these probes would be doing is that they're going to be showing a waveform of the voltage across the resistors. And it's going to be voltage because the probe that I chose was the voltage differential marker. And so let's say that I wanted to compare that to the voltage of the source. I can do the same thing and put some probes down here. And we can leave it like that. And because the probes are now colorful, usually that happens when you already had a simulation running previously. So you can always just click on the previous window and you'll see the waveforms that came about the simulation. But what I like to do beforehand is just always make sure I hit the play button one more time to kind of refresh the window. So going back, we see that the source had the purple probes, and what the probes were measuring for the source was 6 volts. And then the green probe and the red probe were on the resistors. And because they're overlapping, you only see the red, but we can see that they measured, or that it measured 3 volts across the resistors. Another way to see what value was measured through the simulation is that you can go to this toggle cursor icon right here. So again, it's almost on the top right corner. We toggle cursor. And now you're going to have this window down here. So we can see some values that a VR1 was 3 volts, VR2 was 3 volts, and the V source was 6 volts. But let's say you wanted to see what and I believe that this is what the values are at 0 seconds, like time equals 0. So if you wanted to move to, let's say, time equals 0.5 microseconds right here, what you would do is you would click on the color of the circuit element you wanted to measure. So going back to the schematic, we can see that R1 was green, R2 was red, and the source was purple. So let's see, I just wanted to measure the one across R2 specifically. I would go back to the simulation window down here, and I'm going to click on this red diamond. Now, when I click on this red diamond, and then I do a left click on the simulation, I'm going to get this red line that pretty much acts like a probe and follows that that waveform. And so let's say I wanted to follow the purple one instead. I would left click on the purple triangle down here, and now it's going to be following the purple waveform. It's a little bit hard to tell right now because they're both straight lines, but when I change the source in a second, you'll be seeing how it's used and how you can pretty much measure any value at any point in time. Okay, so we confirm that with the simulation on the waveform and on the circuit itself that the values for voltage across R1 and R2 met our expectations. So now what I want to do is I want to change this 6-volt DC source to a sinusoidal source. So what I'm going to do first is I'm going to be deleting these probes, and you'll see why in a second. So I'm just going to left click on them, make sure it's highlighted. I only need to highlight one, and because they're a pair, when I delete one, it'll delete the other. So this one is highlighted, I'm going to hit delete. Same for the green, and same for the red. So what you can do is you can just click on this 6-volt DC source and delete it as well. But let's say you didn't want to delete the circuit and you wanted to keep it for reference, say you wanted to come back to it. What you can do is you can create a new page within PSPICE, and then you can just have multiple circuits and they won't interfere with each other at all. So what I'm going to do is I'm going to left click and I'm going to highlight all of these, and everything here is highlighted in pink. And I'm going to hit Control C, or you can also, I believe, right click and copy. So I'm going to copy that. And then I'm going to go to this icon right here on the top left where it says create document. And by default, it's going to go page 2. So we were on page 1 before. Now it says page 2. I'm just going to hit OK. And now it just gives me a fresh new interface to work with. So again, I'm going to zoom in. And now I'm just going to paste what I copied. So I'm going to hit Control V. And you can see that we indeed copied it, and you can just paste it wherever you want. So I'm going to place this like so. I'm going to hit Escape. And then now it's just like another regular circuit. So again, I want to change the 6-volt DC source to a sinusoidal voltage source. So I'm going to leave the resistors alone. I don't think we need to change those at all. I'm going to highlight the 6-volt DC source, and I'm going to hit delete. And now we see that we have this open gap, and that's not going to be a problem because we're going to be inserting the sinusoidal voltage source. So what I would like to do now is I'm going to go to PSPICE. Oh, sorry, I'm going to go to Place. I'm going to go to Place, PSPICE component, Source, and then we want the sinusoidal voltage source. I'm going to go to Voltage Sources, and then we're going to go to Sign. Now we're going to get this icon right here. It's a little bit different than the DC source, but so I'm just going to connect it to the same 2 lines. And then again, the icon is still following me. It's not going to go away until I hit Escape. I'm going to hit Escape again, so that's not highlighted. Okay. So now what I want to do is I want to change the parameters on the voltage source now, or on the source in general. Again, we're going to leave the resistors alone. Those are fine. So what I would like to do is click on V off. And I'm going to set this to 0. This is the DC offset. This is not necessary for this circuit in particular, so I'm just going to hit 0. For V amplitude, what the value you want to put in this part right here is what you want the maximum amplitude of the source to be. So we saw that R1 and R2 had a voltage across them of 3 volts when the input voltage was 6 volts. So therefore, I want the maximum amplitude of this sinusoidal voltage source to also be 6. So I'm going to just put 6 right here. Okay. And then frequency is well, of course, frequency. So depending on what the lab manual instructs you to do, you can put 10, 100, 1000. So what I'm going to do is I'm going to put 1000 hertz or 1K. So if you put 1K, PSPICE is going to register that this is 1000. And then for AC, we don't need that for this circuit again. So I'm just going to put it as 0. Okay. So now we have this circuit right here. One thing I do want to mention is that this frequency, what the value put right here in frequency does matter, as it's going to affect the simulation. One thing I do want to also mention is that when you are changing the value of the circuit elements, you want to make sure that you just click on the number rather than the item itself. So if I click on this number 10, I get this window right here, which is what we did earlier for changing the value of the resistor. But let's say I double clicked on the resistor instead, then we're going to get this window. But we don't want this because this messes with the properties of the model of the item. But since we don't need to be editing those at all, I'm just going to hit X right there. And now we're back to normal. Okay. So now before I simulate this circuit, what I want to do is change the simulation profile settings. So one way to do that is to go next to the play button right here and edit simulation profile. Or another way to do it is to go to PSPICE and then edit simulation profile like so. So earlier we were doing the transient analysis with the DC source, and the run to time didn't really matter. But when you're working with the sinusoidal source, it does matter, because depending on what your frequency is, it will tell you how long it'll take for the one period to be completed, right? So if we recall, that period is equal to 1 divided by the frequency. So then our period would be 1 divided by 1000, which would be 1 millisecond. So I do want to change that to the run to time then setting. So I'm going to go double click here, and I'm just going to put 1M, and PSPICE is going to register that as 1 millisecond. I'm going to hit apply, and I'm going to hit OK. But since we deleted the probes from before, we're going to have to reattach them. And the reason why I deleted them from the previous page is because if I had left them on the previous circuit and then put more on the new one, we would have all of those waveforms crowded on the simulation window, and we don't want that. So that's why I went and deleted them. But now we want them back on this new circuit. So I'm going to go to the voltage differential markers again up top with the 2 prongs. And then I'm going to start from left to right and then top to bottom. And then typically when you're working with sinusoidal voltage sources, you always want to compare the outputs to the inputs. So I want to make sure that I put them on the source as well. And this time you can see that the probes were grayed out compared to the last one where they were already colored. But once we hit the run, they should turn colorful. So I'm going to hit escape, and then I'm going to go to the play button and hit run. Okay. And now we see that the waveforms have been simulated. So the red and the green are overlapping again. Those are the resistor voltages. And then the purple one is the source. So we can see that when the source is at its maximum amplitude of 6 volts, the voltage across the resistors is roughly around 3. And we can double check that by going again to this toggle cursor. And I want to see I want to measure the voltage across the resistors. So I can click on the green or the red. So I'm just going to left click on the red one. And we can see that this cursor is following the red and green waveform. But let's say that I wanted to measure the source. So what I want to do is I want to left click on the purple triangle, and now the cursor is following the purple waveform, not the red one. So this simulation right here is showing one period, but let's say you wanted to have it show more than one period. So what I can do is I can go back to the edit simulation profile, and then I can change this run to time from 1 millisecond to, let's say, 3 milliseconds. So now this is going to show 3 periods. I'm going to hit apply, hit OK, and then play this, click on the play button to run the simulation once more. And then now we do get 3 periods. So now the waveform is a little bit better to see, and it becomes more apparent on what's going on with the waveforms. So going back to the circuit, I do want to mention one thing. A lot of times in the lab manual, it will say to put a source like, let's say, 10 volts peak to peak. So what that means is that the maximum amplitude would be 5 volts, and the minimum amplitude would be negative 5 volts. So going from top to bottom, that would be 10 volts altogether. So when you're using the sinusoidal source, if it tells you they want 10 volts peak to peak, because the maximum amplitude would be 5 volts, that you're going to want to put 5 volts on this V amplitude right here. And you can see that too. So let's say I wanted 6 volts peak to peak. When I go back to the waveform, the maximum amplitude is 6 volts and the minimum amplitude is negative 6 volts. So this is actually 12 volts peak to peak. And if I wanted to make it 6 volts peak to peak, I would change this then to 3. I would hit OK, run the simulation again. And then you can see now the maximum amplitude of the source is now 3 instead of 6. And then that also affects what the voltage across the resistors would be. So this looks like it would be around 1.5. And following my cursor, it does say it's about 1.5 volts. So again, that met our expectations, as when the input voltage is changed, then so would the voltage across the resistors. So finally, what I want to do is I want to do another circuit like this, but instead of having the sinusoidal voltage source, I'm going to have a pulse train or a square wave. So again, I'm going to be deleting all these probes. And then I'm going to copy everything. I'm going to highlight everything and I'm going to copy it. Control C. And I'm just going to create one more page. So I'm going to go to this top left icon right here. It says create document. And then it's going to name it page 3. So if you want to leave it like that, it's fine. And now we have another blank interface. I'm going to zoom in, and then I'm going to copy it down. Okay. So now that I have the circuit, I'm just going to change the source. So I'm going to go delete the sinusoidal voltage source, and I want to now put it with a pulse train, or sometimes they may refer to a square wave. So I'm going to go back to place, up on the top left toolbar, PSPICE component, source, voltage sources, and then pulse. Now we're going to get this icon right here. So putting them on the same 2 lines, like so, hitting escape. Okay. So as far as parameters go, V1 is the starting point of the waveform, basically. So let's say I wanted this waveform to travel from negative 6 volts to positive 6 volts. So I would double click on this V1, and I would put negative 6. And then for V2, because this is where I want it to go up to, be positive 6. Now these values, TD, TR, and TF, technically these should all be 0, but for PSPICE, it registers it better when you do 1 e to the negative 9. So for TD, I'm going to do 1 e to the negative 9. Same thing for TR, 1 e to the negative 9. And then same for TF. Okay, so period and PW. Period is how long you would want the period to be. So let's say I wanted this to be, if the frequency was 1 kilohertz again, then the period would be 1 divided by 1,000, which would be 0.001. So on here on period, I'm going to do 0.001. Oops. And now for PW, this is always going to be half of what your period is. So this is going to be 0.0005. Okay. Now that we have these parameters changed, we're going to go check the simulation profile again. Because the period is 1 millisecond, so this would be 3 cycles once more. So I think we just leave it like that. So I'm going to hit OK. And then I'm going to hit the play button once more. Oops. One thing I actually forgot to do was to put the probes on once more. So I'm going to go to the voltage differential markers. I'm going to go from left to right, like so. And like so. If it becomes hard to see where the pins are for the connections, I forgot to mention, but I've been connecting the probes on the pins of the element. So you can see with this little red line, that's where I've been connecting the probes. So if that's a little hard to see, you can always click on the boxes where the values of current and voltage are showing, and you can just move it up. Okay. So now let me run the simulation once more. Okay, so this might be a little bit hard to see given that my background is a little dark, but we see that the square wave reaches a maximum value of 6 volts, and then it looks like the voltage across the resistors is about 3 volts. So we can confirm that again with the cursor. And if I want to follow the red one once more, going on the waveform or the simulation, if I'm following the red waveform in particular, I do get 3 volts for both R1 and R2, because again, they are the same value, so the waveforms are overlapping. Okay, and then another thing that I wanted to also show was with these probes, I've only been showing what the voltage is across these circuit elements, but you can also use the current marker, and this is to measure the current across these circuit elements as well. So this one is just going to be one single probe. And like I mentioned earlier, how these probes do want to be connected to those pins of the circuit element, I have to connect it to one of these right here. But I don't want them to be overlapping the previous probes. So I'm going to hit R and rotate it, and I'm going to place it like so. And it may look a little strange, but it's going to work exactly the same. So you can just leave it like that. I'm going to hit play again. And now you would see there is a small yellow waveform. And that one is going to be the current throughout the circuit. Okay, so that is pretty much the basics of PSPICE. I hope this quick tutorial was helpful. And if you are able to at least master these basics, then I think you'll be fine for the rest of your semester. And then eventually you will be comfortable enough with PSPICE that these things would come naturally to you. Thank you for watching. And again, I hope this was helpful.